Algebra Honors, Unit 7, Day 8. We are going to factor by grouping, and we are going to, sorry, I don't know if that was in your way. We are going to factor by grouping, and we're going to have 4-term polynomials that we are factoring. So, let's look at our first one. Let's just dive in and start on it, okay? 12a cubed minus 9a squared plus 4a minus 3. If I factor by grouping, I'm going to take my first two terms and my second two terms, and I'm going to see what I can factor out of each of those, right? So 12a cubed minus 9a squared, I can take 3a squared out of those. I'm left with 4a, right? 12a cubed divided by 3a squared, 12 divided by 3 is 4, a cubed divided by a squared is a. Negative 9 divided by 3 is negative 3, and a squared divided by a squared is just 1, so that stays like that. Over here, I have 4a minus 3. Well, that's lucky, so I'm going to say this is plus 1 times 4a minus 3. Okay, I'm doing that so that I can pull 4a minus 3 out of each of these big terms. So I'm going to divide by 4a minus 3. 3a squared times 4a minus 3 divided by 4a minus 3 is just 3a squared. And 1 times 4a minus 3 divided by 4a minus 3 is just 1. Okay, I pulled out that 4a minus 3 and I was left with 3a squared plus 1. So that is how we get to factor that big polynomial. 12n cubed plus 4n squared plus 3n plus 1. So I will say, so you always still want to look and see if there's a greatest common factor to pull out first. I should have said that with the last one and I didn't. You always want to keep that in mind. But here I don't see any greatest common factor I can pull. I can't combine any terms. So I'm going to look at my first two terms and see what I can pull out. It looks like 4n squared times 3n plus 1. And over here, 3n plus 1 again. I'm going to say that's plus 1 times 3n plus 1. Because now I can pull 3n plus 1 out. I have 3n plus 1 times 4n squared plus 1. That would be my answer there. And I always want to look again to see, is there any way to break those guys up? Do I happen to have a difference of squares or something? But no, not yet. Look for a greatest common factor, 2, 5, 6, 15. Nope. So I'm going to look at the first two, and I'm going to pull out just p squared. That leaves me with 2p plus 5. I'm going to pull out 3, so that's 3 times 2p plus 5. Well, that's lucky because I have that matching binomial. So I'm going to pull out 2p plus 5. Pull 2p plus 5 from each of those, and I'm left with p squared plus 3. Okay. 3n cubed minus 4n squared plus 9n minus 12. I don't see any perfect, any greatest common factors rather, okay? But I'm going to break this down into, and I'm hoping I do my positives and negatives correctly. Let's see. I'm just going to pull n squared out here, n squared, and I'm left with 3n minus 2, right? 4n squared minus n divided by n. Oh, nope, it's 3n minus 4, forgive me. Okay, and over here I have 9n minus 12, so if I take 3 out, that leaves me with 3n minus 4. Well, good, that worked, because I was hoping to have a matching binomial, so 3n minus 4 times n squared plus 3. Okay, you know you can always check your work by multiplying all that stuff back together again.